Hello everyone. In this video, we'll look at measures of central tendency. These identify a single representative value that is basically the center of the data set to summarize the data. There are different kind of central tendency measures that we often use in mean, median, and mode. In this video, we'll only look at different types of mean calculations, including arithmetic mean, weighted arithmetic mean, geometric mean, uh, harmonic mean, and the trim mean. And we'll also look at how these arithmetic, geometric, and harmonic mean values compare with each other. Um, okay, so let's see how we could calculate arithmetic mean. So this is the formula that we're going to use to calculate the arithmetic mean. It's very simple. We need to first calculate the sum of all values and then divide this sum by the total number of values, that is n. And for weighted arithmetic mean, so the formula changes uh, to this equation. So here we first multiply each value in the data set by its corresponding weight, and then take the sum of this resulting value over the entire data set, and then divide it by the sum of all weights. And we could see that in arithmetic mean, we are assigning equal weights to all values. So this is kind of a special case of the weighted arithmetic mean with equal weights to all values in the data set. Okay, so now let's look at the geometric mean. In this mean, instead of summation, as we saw in the arithmetic mean, we take the product of all values in the data set and then take the nth root of that product. So that gives us the geometric mean. This is useful when we are dealing with data set that grow exponentially. For example, data set related to population growth. Uh, in the harmonic mean case here, we divide the total number of values by the sum of the reciprocal of all the values. So here you could see that we are assigning more weights to smaller values. So the harmonic mean is used in cases when we are dealing with rates or ratios. Finally, the trim mean. So sometimes we simply want to remove some outliers from our distribution. So basically the smallest and some largest values, and calculate the mean of the remaining values just to get more stable results. Um, so that is trim mean here. So we remove the specified percentage of the smallest and largest values from our data set. Um, okay, so these were different kind of means calculations. So let's see how the arithmetic, geometric, and harmonic means compare. Typically, harmonic mean values are smaller or equal to the geometric mean values, which are typically smaller or equal to the arithmetic mean values. So arithmetic mean values are typically larger than both or equal to both H and G. Okay, let's do some mean calculations using this example data set here. So this is an arbitrary data set that I created for this example only. So we'll use this data here. So in this list here, and then try to compute in task A the arithmetic mean. In task B, we'll be calculating the weighted arithmetic mean, assuming that all values greater than 4 are weighted twice the remaining values. In part C, we'll calculate the geometric mean, and in D, we'll be calculating the harmonic mean. And we'll only use Python, and we won't be using any NumPy library in this video. Okay, so I have created a variable x and assigned the input data list to it. Okay, so let's first create another variable and set it equal to total number of values in the data. So, and now let's calculate arithmetic mean, basically task A. So we've seen that arithmetic mean is the sum of all values divided by the total number of values. So a mean is equal to sum of all values divided by n. And if we want to see what that value is, so that is 4.59. Okay, so now moving on to task B, which is weighted arithmetic mean. And we are assuming that all values greater than 4 will be weighted twice than the other remaining values in the data. So let's create a weight matrix, list of weights, sorry, not the matrix, just the list of weights. So we have lambda function here. So lambda, we'll assign it to 2 if x is greater than 4, else it should be 1, and the input is the array. And if we want to look at this weight list, list of weights, so for the values that are greater than 4, weight is equal to 2, whereas for the values that are smaller than 4, the weight is equal to 1. So this 1, 2, 3, 4, 5, 6, seventh value here, 1, 2, 3, 4, 5, 6, and seventh is 2.4. So the weight assigned to it is 1. So this is good. Okay, so now let's see if we want to multiply it with each corresponding value. Weighted a mean would be equal to sum of, so we say wi times xi for wixi in zip of w and x, and divided by sum of w. And let's see what value do we get. So the weighted average in this case is 4.78. So what we are doing, we are using the zip function and getting a list of tuples here. So uh, each entry will be delivered as a tuple. So we are unpacking that tuple into wi into an xi and then multiplying these two values. So that is the part here. So wixi sum, and then sum of weights, we could simply use sum of w. All right, so that was task B. Now let's look at task C, which is geometric mean, sorry. Okay, and G mean would be, so we need to calculate the product of all values in the data set. We could basically use the reduce function from functools, import reduce. We could use that, or we could also use the math library from there. Okay, so first let's do this using math library. So math dot power, so math dot prod, and then give it the list as an input, and the power is 1 by n. So this is the geometric mean, which is equal to 4.45. Okay, so now if we don't want to use the math library, so we could also calculate it using the reduce function. So we use reduce, and then we write a lambda function, so x and y, and then we take the product of x and y, so the input is the array, and then we take the power 1 by n, and this g mean should also be equal to the 1 that we calculated previously, so which is 4.45, the same as before. Okay, so that was task C. Now let's look at the harmonic mean. So the task D, harmonic mean. Okay, so H mean is equal to, and is the sum of the reciprocal of all values in the data, and then we divide total number of values by the sum of reciprocal of all values here. So n divided by sum 1 by x for x in x. So we could write it like that. So that is h mean 4.2961. But if we want a solution with the reduce function, so we could also do that. So x, y, and then we need to do 1 over 1x plus 1 over 1y, and the input to this reduce will go as the input list x, and we need to multiply this with the total number of values. So if we check whether we are getting the same h mean, so this is exactly the same h mean here. Okay, so now let's see how h mean, g mean, a mean compare. So h mean smaller or equal to g mean, that is true, and g mean smaller than equal to smaller or equal to a mean, that is also true. Okay, so in this video we looked at different type of mean calculations. We only used Python and to calculate these mean values, and in Python we also looked at functools reduce function and also the math library for these calculations. All right, okay, so that's it for today's video. I hope you like this video. Um, yeah, thanks for watching, and see you all in the next video, where we'll be looking at the same problem of mean calculation, but using NumPy library. Thank you.